Hello all, welcome to my channel. So today we will learn about tunnel diode, and a tunnel diode is made up of a semiconductor p-n junction diode. Provided here the p and n sides both are heavily doped or made up of degenerate semiconductors. So it can be said that it is a high conductivity diode which is doped heavily about 1000 times higher than conventional diode. And here it also says the Isaki diode and symbol is also shown. Due to very thin depletion layer, the carriers actually tunnel through. We can say electrons from conduction band can move with the enough kinetic energy because the charge carriers can tunnel through the barrier, which is 0.3 volt in the case of germanium and 0.7 volt in the case of silicon. So a conventional PN diode is doped by impurity atoms in the concentration of 1 part in 10 to the power 8, and with this order of doping, depletion layer is wide and there exists a potential barrier. But in Isaki diode or tunnel diode, the barrier reduces, there is a very thin depletion width, and due to this the electrons will tunnel, and this is also known as quantum tunneling mechanical behavior. So this is actually very much doped, about 1000 times greater than, and the depletion width reduced to 10 to the power minus 6 centimeter, and device characteristic completely changed in tunnel diode. And you can say many carriers can punch through the junction even when they do not have enough kinetic energy to overcome the potential barrier, as I have explained earlier. So this is a very useful diode. So what happens is there is a large amount of forward current produced even when there is a bias voltage less than 0.3 volt or 7 volt, 0.7 volt. This figure shows the tunnel diode volt ampere characteristics. So what happens is before the peak value voltage Vp, there is a tunneling current which is very high, because when you increase the voltage, the current will also increase. This is due to the tunneling effect and not due to the forward bias effect. This is when the injection current is very small and the holes are enough on the p side, and electrons tunnel from n side of the region to the p side where empty states of holes are present in large amount. But after certain amount of Vp, the forward bias will affect the holes on the p side and it will reduce, so the current will also reduce, and therefore this resistance, negative resistance, comes into existence. So from Vp to Vb, the current will reduce when voltage is increased, but after the valley voltage, the current will increase as in the forward biased diode.